Hi everyone, in this video we're going to be doing A-Level Maths 9709, Paper 55, Probability and Statistics 1, May June 2025. This paper is 1 hour 15 minutes long, so we'll try to finish within that time limit. So without further ado, let's get started. Okay, so for the first question, we're told that two fair six-sided dice with faces labeled 1, 2, 3, 4, 5, 6 are thrown. And the two scores are noted, and the random variable x is defined as follows. So if the two scores are equal, then x would be equals to 0. And if they're not equal, then x is the larger score minus the smaller score. So you can think of this as the differences between the scores, the absolute, the difference between the scores obtained. So first part, we have to draw up the probability distribution table for x. Okay, so first of all, let's find out all the possible values of x and the respective probabilities. So in order to find the values of x, I can draw a table like this. So for this first row, it would be the faces of the first die. So 1, 2, 3, 4, 5, 6. And this one would be the faces of the second die. 4, 5, 6. Okay, now we're gonna take the difference of the two numbers. So this is 1 and 1, so this would be 0. 2 and 2, this would also be 0. So 3 and 3, 4 and 4, 5 and 5, 6 and 6. So we're just taking the difference, okay? And so 2 and 1, this would be 1. 3 minus 1, that's 2. 4 minus 1, that's 3. 5 minus 1, 4. 6 minus 1 is 5. And then for 2 minus 1, that is 1. 3 minus 2, 1. 4 minus 2, that's 2. 5 minus 2, that's 3. 6 minus 2, that is 4. And then for 1, 3, that's going to give us 3 minus 1. So 2 and 3, that's 3 minus 2, that's 1. And then 4 minus 3, that is 1. 5 minus 3, that's 2. 6 minus 3, that is 3. And 1 and 4, that's 4 minus 1, which is 3. 2 minus 4, that's 2. 4, that's 4 minus 3, which is 1. 5 minus 4 is 1. 6 minus 4 is 2. And 1, 5, that's 5 minus 1, 4. 2 and 5, 5 minus 2, that's 3. 3 and 5, 5 minus 3, that's 2. 5 and 4, that's 1. 6 and 5, that's also 1. And this one is 2, 5, 6 minus 2, 4, 3. These are possible values for x. Okay. Yeah, so these are possible values for x. Now we know the possible values. So now we can start to draw our probability distribution table. So let's list down all the possible values of x first. So this is supposed to be small x. So we got 0, 1, 2, 3, 4, and lastly 5. The second one is the probability of big X equal to X. The probability of X being equals to 0. Let's count the number of zeros. That's 1, 1. Sorry, that means the highlighter here. Okay, this is the highlighter, so there's one. Oh my goodness. 1. You know what? Never mind. Yeah. Just count manually. So 1, 2, 3, 4, 5, 6. And in total, there is 6 by 6 cells. So there's 36 cells. So 36, 6 is a 0. So this is probability of x being equals to 0. Now for x equals to 1, let's count the number of ones. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10 out of 36. And for 2, there's 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 over 36. And for 3, there is 1, 2, 3, 4, 5, 6. Yeah, so there's 6, 3. And for 4, there is 1, 2, 3, 4. So that's 4 out of 36. And finally, for 5, there's only 2. So that's 2 out of 36. And to check whether all of our probabilities here are correct, just add these up. They should all add up to 1. So if it doesn't, it means you've gone wrong somewhere. So let me just do that quickly. Yep, they all add up to 1. So this is our final answer for this first part. Let's head on to the next part. Okay, so now we have to find the EX and the variance of X. Okay, so to find EX, the formula is given in the MF19, right? And probability and statistics and the discrete random variables. So it's right here. EX is just the summation of P times X times P. Okay, so summation of X times P. So this just means it's the sum of all the X values times the corresponding probability. So it will multiply the X value 0 and multiply the probability of the X value. Let's do for 1, so 1 times 10 over 36 plus 2 times 8 over 36 plus 3 times 6 over 36 plus 4 times 4 over 36 plus 5, 2 over 36. Just type it into your calculator. 16 over 36 plus 18 over 36 plus 16 over 36 plus 10 over 36. So you get 35 over 18. Your answer should be more than 1 for this. Okay, now let's find the variance of x. So the variance of x is the formula is given in the MF19. It's right here. Is the summation of the probability times the corresponding x value squared minus the expectation squared. Okay, so let's write it down. Minus EX squared. So this one is just 0 squared times 6 over 36 plus 1 squared 10 over 36 plus 2 squared 8 over 36 plus 3 squared 6 over 36 plus 4 squared. Okay, I'm squaring the correct number. 4 over 36 plus 5 squared 2 over 36. And all this minus the expectation squared, so 35 over 18 squared. So this would just be 6 over 36. It's 1 squared, 10 over 36. It's 2 squared, 8 over 36. Plus 3 squared, 6 over 36. Plus 4 squared, 4 over 36. Times 5 squared, 2 over 36. Minus 35 over 18 squared. You would get 665 over 324. And you can leave your answer in this exact form. So this is our These are final answers for this part as well as the entire question. Let's head on to the next question. Okay, so for this question, we're told that the heights of trees in a certain forest are classified as tall, medium, or small. And the heights can be modeled by a normal distribution with mean 20 meters and standard deviation 5 meters. Trees with a height of less than 14 meters are classified as small. And for the first part, we're told for 150 randomly chosen trees from this forest, how many would you expect to be classified as small? Okay, so basically they're telling us to find how many trees would we expect to have a height of less than 14. So first we'll let x be the height of the trees, and we'll define x as having a normal distribution of mean 20 meters and variance 5 squared. Yeah. And we're told to find the probability. First, we should find the probability of the tree having a height less than 14 meters. So probability of x being less than 14. And to find this probability, we first have to standardize this. Okay, so let's find the z-score. So z-score would just be the x value 14 minus mu over the standard deviation. You will obviously get a negative value for this. 14 minus 20 divided by 5, you'll get minus 1.2. And then this is phi, you can write this as phi minus 1.2. And this phi minus 1.2 in our formula sheet, we can use this relation to rewrite it as 1 minus phi 1.2. So now we can use our normal distribution tables to find phi 1.2. Okay, so to do that, look for 1.2 under the z column. So we find it here. Okay, so 1.20, we get 0.8849. So this is 1 minus 0.8849, which would give you 0.1151. And to find the number of trees, you just multiplied by 150. So doing this will give you 17.265. And since we're counting the number of trees we expect, we should round it off to the nearest whole number, either 17 or 18. So I'm going to go with 17. So nearest whole number. So this is the final answer for this question. Let's head on to the next part. Okay, so for this part, we're told that trees from this forest are classified as tall if their height is at least h meters. And we're told that 25% of trees are classified as tall. So using this information, we have to find the value of h. Okay, so to be classified as tall, x has to be more than or equal to h. And the probability of x being equal to more than h is 25%, which is also 0.25. Okay, so in order to use the normal distribution, we can rewrite this as 1 minus p x less than h equals to 0.25. And we can make p x less than h as a subject of the equation. So this would just be 1 minus 0.25, which is 0.5. Okay, now let's standardize this by finding our z-score. So z would be less than h minus mu. Mu is 20. And then the standard deviation is 5, equals 0.75. We can write this as a function of phi h minus 20 over 5, equals to 0.5. So to find out what the function inside phi is, h minus 20 over 5, we can use the normal distribution tables in reverse. So instead of looking at the z column, we'll now look at the phi values. So to find 0.75, we'll look for the value that is less than that's closest to 0.75 and less than 0.75. So in that case, that would be this value. And to make the 0.75, you just have to add 14 to the last two digits. So now let me look for 14. Yeah, so, okay, unfortunately, we can't find 14. Okay, wait, let me check again. Classified as tall. Okay, so 0.75. 0.75. Okay, 13 is the closest value. Yeah, it's 0.7499 if you choose 13. Yeah. Yeah, so this is the closest value we got. Or we can just use this. So 0.75. Yeah, we have this. So this would just be 0.674. Okay, so write this. Gosh, can equate. Oh, we can equate this h minus 20 over 5 as 0.674. And make h the subject. So 0.674 times 5, that is 3.37. And h would be equals to 20 plus 3.37, which is 23.37 meters. So this is our final answer for h. And we've also come to the end of this question. So let's head on to the next question. Okay, so for this question, we're told that in a certain large school, on average, 2 pupils in 5 have music lessons. And we're told that a random sample of 80 pupils from this school is chosen. For the first part, we're told to use an approximation to find the probability that fewer than 27 pupils have music lessons. Okay, so to do this, we must first identify what distribution we should use to calculate the probability. So here we have a finite number of trials, like we picked up a finite number of students, and from that finite sample, we're supposed to find less than 27 instances of success. So clearly this is a binomial distribution where n is 80 and the probability of success, aka the probability of having music lessons, is 0.4. Okay, and the approximation that they're telling us to use in here is the normal approximation to the binomial, okay? So in order to do that, we first have to see if they meet our conditions. So the conditions to use this approximation is that NP should be more than 5 and NQ, the Q is the probability of failure, should also be more to 5 and N should be more than 30. So let's check these quickly. Okay, so 80 times 0.4, that's 32. And 80 times 0.6, that is 48. So clearly both of these are way more than 5, so we can use this probability. So first of all, in order to convert this to the normal, to use the normal approximation, we have to find our mu, the mean, which is n times p. It's given in your MF19 right here. Mu equals n times p. So that's just 80 times 0.4, which is 4 times 8, that's 32. And sigma squared, it's also given. It's n times p times 1 minus p. So that's 80 times 0.4 times 0.6. So this gives you 19.2. So now this has the normal distribution where mu is 32 and the variance is 19.2. Okay. All right. So we want to find out whether X is less than 27. So X is the number of students that take music lessons in here. So now we're gonna standardize it. Okay, so we have to note that since we are using continuous distribution to approximate a discrete distribution, that we should do the continuity correction. Okay, so 27, less than 27. This only like this is applicable. This is not included. So we cannot have 27.5. We can only take 26.5. Okay. So Z is going to be 26.5 minus mu, which is 32 over the standard deviation square root 19.2. And this would be equal to 26.5 minus 32 divided by square root 19.2. This would be minus 1.255. The reason I'm rounding off to 3 decimal places is because that's the maximum number of decimal places you can use for your normal distribution tables. And we can convert this into a function of phi, 1.255. We can obviously rewrite this as 1 minus phi, 1.255. As there's a form, as per the formula given in the normal distribution table. So now let's use our normal distribution table. So let's look for 1.2. So it's right here. Now let's look for 5 and again 5. So 1.25, we get 0.894. And then for 5, we have to add 9. So 0.8944 plus 9. This gives us 0.8953. So this is 0.8953. So this will give you 1 minus 0.8953. This is 0.105 to 3SF. So this is a final answer for this first part. Let's head on to next part. Okay, now we're told that a random sample of 10 pupils from this school is now chosen. And the second part, we have to find the probability that no more than 2 pupils have music lessons. Okay, so to do this, we basically have to find the probability that x is less than or equal to 2. So this is obviously equals to p x equals to 0 plus px equals to 1 plus px equals to 2. So if you can't tell, this is also a binomial distribution where n is 10 and probability of success is 0.4. Yeah, so to find the probability, formula is given in your MF19, which is this. Okay, so R is the x value, right? So this is going to be n. Choose 0 times 0.4 to the power of 0 times 0.6 to the power of 10. This means plus 10, choose 1 times 0.4 to the power of 1 times 0.6 to the power of 9. And this is plus 10, choose 2 times 0.4 to the power of 2 times 0.6 to the power of 8. So for all the powers, you must make sure that they add up to 10. So 0 plus 10 is 10, 1 plus 9 is 10, and 2 plus 8 is 10. And for the probabilities in the brackets, they should both add up to 1. Okay, so just type all this into your calculator. So this would give you 0.1673 SF. Yep, so okay, so this is final answer for this part. Let's head on to the next question. Okay, so for this question, we're told that students applying to Drysdale College take an entrance test, and the outcome is the student is either accepted or rejected or required to take another test with probability 0.3, 0.2, and 0.5. So getting accepted, it's 30%, and rejected is 20%, and second test is 50%. Okay, and then after that, we're told that when a student takes a second test, the outcomes and probabilities are exactly the same as the first test. Okay, so it's also 0.3, 0.2, and 0.5 with the same outcomes. And then after that, a student who has to take a third test is accepted with the probability of 0.25 and rejected with probability 0.75. Okay, so for the first part, we have to draw a tree diagram to illustrate this information, showing all probabilities. Okay, so first, let's draw the first stage when the students take the first entrance exam. So the probability of that we got accepted, that is 0.3, and then rejected, that is 0.2, and test, we'll write it with the letter T, that's 0.5. And then for the test, they're required to take another test, so it's also going to be the same outcomes. So A, R, T. So acceptance, probability 0.3, rejection 0.2, and T, another test is 0.5. And then for these students who have to take a third test, we have only two outcomes. So acceptance or rejection. So acceptance is 0.25 and rejection is 0.75. So this is our final answer for this first part. Let's head on to the next part. Okay, now we have to find the probability that a randomly chosen student who applies to Drydale College is accepted. Okay, so let's use our tree diagram to see the ways of getting accepted. So we can see either you can get accepted on your first try, or you can take two tests and get accepted. So like this, or you can take three tests and get accepted. So if you take one test, your probability would just be 0.3. And then you add it with the probability of taking two tests and getting accepted. So that's 0.5 times 0.3. And then probability of getting accepted after taking a third test, that's 0.5 times 0.5 times 0.25. Okay, so you add all these three probabilities up. You get 41 over 80. So this is our final answer for this part. Let's head on to the next. Okay, so for this part, we're supposed to find the probability that a randomly chosen student who applies to Drydale College takes at least two tests, given that the student is accepted. Okay, so this is a conditional probability question. So let's write down a probability in the set notation. So there's a probability that student takes at least two T, right? Given that student is accepted. So to find this out, first have to find the probability that the student takes at least two tests and that the student is accepted. The probability that the student takes two tests and is accepted divided by the probability of the student getting accepted. Okay, so in order to find the numerator, let's look at our tree diagram. So in order to get accepted and take at least two tests, you can take two tests and get accepted, so 0.5 times 0.3, or you can take three tests and get accepted, so 0.5 times 0.5 times 0.25. So let's add those probabilities up. So 0.5 times 0.3 plus 0.5 times 0.5 times 0.25. Yeah, over probability of getting accepted, we use our previous answer, 41 over 80. Okay, now just type all this into your calculator. Followed by 41 over 80, you'll get 17 over 41. So this is our final answer for this part. Let's head on to the last part. Okay, so here we're told that three friends applied to Drydale College. And for this part, we have to find the probability that all three are rejected. Okay, so to first find the probability of getting rejected, we just minus 1 from the probability of getting accepted, which is 41 over 80. We're using this probability law. If to find the probability of P prime, is 1 minus p, where p prime is basically p not happening, or the opposite of p. Okay, so this is just 39 over 8t. And to find the probability of all of them getting rejected, we just have to multiply this probability 3 times. So 39 over 8t cubed. This will give us 0.1115 116 to 3SF. So this is our final answer for this part, as well as the entire question. Let's head on to the next question. So for this question, we're told that the smarts and the teasers are two quiz teams that each contain 11 members. Both complete a puzzle, and the following table gives the times taken in minutes by the members of each team. Okay, so for the first part, we have to represent this information in a back-to-back stem leaf diagram with the smarts on the left-hand side. Okay, so to draw a back-to-back stem leaf diagram, let's first draw the main column and then the two side columns. So the timings for the smarts will be here, and this would be the timing for the teasers. Okay, so let's look for the lowest timing. Okay, so for the smarts, that would be 9. And for the teasers, that would be 12. Yep, yeah, 9 and 12. Okay, how do we represent this? Okay, so, all right. So for single digit numbers, I'm just gonna put a 0 in the main stem, and then in the leaf, we'll just put the digit. So this represents 9 for the smarts. Okay. And then for the teasers, it'll be like this. We put the first digit in the stem, and then we'll put the second digit on the leaf. Okay, now let's look for numbers with the first digit 1. So we have for smarts 11, 13, 2 18s. Yeah, that's all. So 11, 13, 18, 18. And then for teasers, we have 12, 15, and 18. Yeah, so 12, 15, 18. Okay, now let's look for the timings where the first digit is 2 for the smarts first. So we got starting with 22, 28, and 29. So 22, 28, 29. And then for the teasers, we start with 21 and two 25s. Yeah, that's all. So this is 21, 25, 25. Okay, and then lastly, let's look for the numbers starting with the digit 3. So for the smarts, we only have 30 and 38. So this is going to be 0. This is going to be 8. And for the teasers, we have 36, 32, 36, 37. So we have 32, 36, 37, and lastly, 239. So 9 here. And for the smarts, we have 41. So let's write 4 in the stem and 1 in the leaf. So this, don't forget to write the key. So the key is going to be 1, 1, 2, represents 11 minutes for smarts and 12 minutes for teasers. So this is our final answer for this first part. Let's head on to the second part. Okay, so in this part, we're told that for the teasers, the values of the lower quartile, median and upper quartile are 18, 25, 37 minutes respectively. And for the second part, on a single diagram, we're supposed to draw box and whisker plots for the two teams. All right, so let's first draw for the teasers. Okay, so to draw a box and whisker plot, this first line would be your minimum, and then the box would consist of your Q1, which is your lower quartile, your median, and then the final other end of the box would be your upper quartile. And then the last line would be your maximum point. So with that, let's start plotting our box and whisker plots. So first, what we should do is to label our horizontal axis. Sorry. By the way, when you're doing this in the exam, please make sure to use a ruler. Okay. So this is time in minutes. Or no, times in minutes. Okay. All right. So let's see. What's the maximum and minimum value? So minimum value is 9 and maximum is 41. So let's keep that in mind and plot our whisker plots. Okay. All right. So we can let this be 10. And let this be 20, 30, and 40. That way each box would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each gap would represent 1. Oh, sorry, this is supposed to be 40. Okay. All right, so let's draw for the teasers first. Okay, so for the teasers, our minimum value, you can see from the diagram, is 12. So 12 is somewhere here. Okay, let's draw it in here for teasers. Okay, that's the minimum, and then lower quartile is 18. So that's 1918. And then median is 25, which is 1, 2, 21, 22, 23, 24, 25 right here. And then per quartile is 37. So that is 40, 39, 38, 37. Okay. And then finally, final value, the maximum value would be 39 for them. 39 is somewhere here. Okay, so let's draw a line connecting that. Let's draw the box. And finally the line again. So this is teasers. All right, and then let's draw one for the smarts. So minimum value for the smarts is 9. Okay, so 9 is here. Okay, so let's start here. This is 9. And then we have to find the lower quartile by ourselves. So to find the lower quartile, just take 1/4 lower quartile position times the number of data points. So in this case, that's 11 plus 1. So you take the third position, the third data point. So that is 1, 2, 3. So that is 13 for us, for the Smarties. So 13 would be 10, 11, 12, 13. So this is lower quartile, now the middle quartile. To find that, take half of 11 plus 1. So get the sixth position. And for the upper quartile, you take 3/4 times 11 plus 1. You'll get the ninth position. So the sixth position is 1, 2, 3, 4, 5, 6. So that's 22. Okay, so 22 is 20, 21, 22. And then ninth position, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is 30, I'm sure. Yep, 30. So upper quartile is here. Okay, and then maximum is 41. So 41, it's somewhere here. Oh, never mind, that's not 41, that's 40. Okay, so 41 should be here. So let's draw the line and the box connecting the mean upper and lower quartile. Finally, the line connecting the maximum point. Don't forget to label it. Yeah, so this is our final answer for this part. Let's head on to the next part. Okay, so for this last part, you're supposed to make two comparisons between the times for the two teams. Okay, so to do that, let's take a look at our box and whisker plot. So as you can see, for the smarts, the box and whisker plot is wider than the teasers. So hence we can say that the timings for teasers is more consistent than the smarts. And now for the second one, let's take a look at the median, okay? So as you can see, the median for smarts is actually lower than that for the teasers, as well as the minimum value. So for that, we can say that smarts are quicker than the teasers. So this is our final answer for this part. Let's head on to the next question. Okay, so for this question, we're told that a darts club has 12 members made up of 7 men and 5 women, and every Monday a team of 4 is chosen at random to represent the club in a competition. For the first part, we're supposed to find the probability that on a particular Monday, the team consists of 1 man and 3 women. Okay, so to do that, let's first. All right. So let's first find the total number of teams, that is possible to make, so that would just be 12 choose 4. 12 choose 4, that is 495. Okay. And then for this particular team, 1 man and 3 women, this is 7 men. From 7 men, you have to choose 1. From the women, there's 5 women. You have to choose 3. So 7 choose 1 times 5 choose 3, you will get 70. Hence, the probability will be 70 over 495, which can be simplified to 14 over 99. So this is our final answer for the first part. Let's head on to the next part. Okay, so for the second part, we're told that every Tuesday, the dart clubs chooses 3 teams of 4, and each team enters a competition in a different town. Okay, so for this part, we have to find out in how many different ways can the teams be chosen if there are no restrictions. Okay, so the keyword here is chosen. So that means this has got to do with combinations where the order doesn't matter. So let's find the combinations. So for the first team, we will have 12 people to choose from to form a team of 4. Okay. And for the second team, we already have 4 people chosen, so we'll only have 8 people remaining to choose from. So 8 choose 4. And then lastly, we'll only have 4 people to choose from, so 4 choose 4. So this is 12 choose 4 times 8 choose 4 times 4 choose 4, which is 1. You'll get 34,650. So this is our final answer for this part. Let's head on to next part. Okay, so for this part, we're supposed to find in how many different ways can the teams be chosen if each team must contain at least 1 man and at least 1 woman. Okay, so in order to do this question, let's first consider the combinations which don't meet this criteria. So one that I can think of right away is 4 men and 0 women. And then we can have, let's also write down the number of men and women. So yeah, 7 men and 5 women. Okay. So we can have 4 men, and then the following one, we can have 3 men, 1 woman, and then we can have 4 women. So this is one possible combination. And the other one can have 4 men plus 2 men, 2 women, and 3 women, 1 man. Okay, let's see if there's any more. Okay, I can't really see much. Okay, can't really see anymore. Yeah, so these are the only ways that don't satisfy criteria. So let's find out the number of combinations for each of them. So for the first one, 4 men, we have 7 men to choose from. So 7 choose 4. times 3 men. So that's 3 choose 3 times 7 1 oh, 5 choose 1 and times 4 choose 4. And don't forget to um, factoring the arrangements of these combinations. So this is also the same as 4 women, 3 men, 1 woman, and 4 men, and so on. So multiply 3 factorial. Okay, you will get 1,500. And then for the second one, we have 4 men, so 7 choose 4 times 2 men, which is 3 choose 2 times 2 women, that's 5 choose 2 times 3 women, which is 3 choose 3 times 1 man. So we would only have 1 choose 1. And don't also forget to factor in the uh, combinations as well, like the order. So this would just be type into calculator. This is 6,300. Okay, now we can subtract the total number of ways that we found in the previous part. So 34650 minus 1,050 minus 6,300, and this will give us 27,300. So this is our final answer for this part. Let's head on to the last part. Okay, so now we're told that the 7 men stand in line for a photograph. 2 of them are brothers, George and Harry. And for this last part, we have to find how many different arrangements are there of the 7 men, in which there are exactly 2 men between George and Harry. Okay. So to do this question, let's first draw 7 slots. 5, 6, 7. Okay, so we'll let George and Harry be here for now. Okay, so we'll let this be 1 slot. Okay, let this be 1 slot. All right. So for this position, there's 1, 2, 3, 4, 5 factorial ways to arrange the remaining men. And then we also have another way where George and Harry are here. That is also 5 factorial ways, as well as here and here. That is also 5 factorial ways, as well as here and here. So that's that's 1, 2, 3, 4 ways. So that is 5, 5 factorial times 4, which would give you 480. And then we have 5, and then we can also consider the case where instead it's Harry and George here, and the remaining 3. So this would also be 5 factorial times 4, it's 480. So let's add these 2 cases up together. 480 plus 480. We would get 960 arrangements. So this is our final answer for this part. And this was the entire question, and we have come to the end of this paper. So I hope you found this video helpful. If you did, please make sure to like and subscribe to this channel and share this video with anyone who might find this video useful. And if you have any queries or doubts or um, any future video ideas or what I can improve on, feel free to leave them down in the comments below. And I'll see you again next time. Okay, thank you.